The Pentium II brand refers to Intel's 6th-generation microarchitecture and x86-compatible microprocessors introduced on May 7, 1997. Containing 7.5 million transistors, the Pentium II featured an improved version of the first P6-generation core of the Pentium Pro, which contained 5.5 million transistors. However, its L2 cache subsystem was a downgrade when compared to Pentium Pros. In early 1999, the Pentium II was superseded by the almost identical Pentium III, which basically only added SSE instructions to the CPU. In 1998, Intel stratified the Pentium II family by releasing the Pentium II-based Celeron line of processors for low-end workstations and the Pentium II Xeon line for servers and high-end workstations. The Celeron was characterized by a reduced or omitted on-die full-speed L2 cache and a 66 MTS FSB. The Xeon was characterized by a range of full-speed L2 cache, a 100 MTS FSB, a different physical interface, and support for symmetric multiprocessing. Overview: the Pentium II microprocessor was largely based upon the microarchitecture of its predecessor, the Pentium Pro, but with some significant improvements. Unlike previous Pentium and Pentium Pro processors, the Pentium II CPU was packaged in a slot-based module rather than a CPU socket. The processor and associated components were carried on a daughter board similar to a typical expansion board within a plastic cartridge. A fixed or removable heatsink was carried on one side, sometimes using its own fan. This larger package was a compromise, allowing Intel to separate the secondary cache from the processor while still keeping it on a closely coupled backside bus. The L2 cache ran at half the processor's clock frequency, unlike the Pentium Pro, whose off-die L2 cache ran at the same frequency as the processor. However, the smallest cache size was increased to 512 KB from the 256 KB on the Pentium Pro. Off-package cache solved the Pentium Pro's low yields, allowing Intel to introduce the Pentium II at a mainstream price level. This arrangement also allowed Intel to easily vary the amount of L2 cache, thus making it possible to target different market segments with cheaper or more expensive processors and accompanying performance levels. Intel notably improved 16-bit code execution performance on the Pentium II, an area in which the Pentium Pro was at a notable handicap. Most consumer software of the day was still using at least some 16-bit code, because of a variety of factors. The Pentium II went to 32 KB of L1 cache, double that of the Pentium Pro, as well. The Pentium II was also the first P6-based CPU to implement the Intel MMX integer SIMD instruction set, which had already been introduced on the Pentium MMX. The Pentium II was basically a more consumer-oriented version of the Pentium Pro. It was cheaper to manufacture because of the separate, slower L2 cache memory. The improved 16-bit performance and MMX support made it a better choice for consumer-level operating systems, such as Windows 9X, and multimedia applications. Combined with the larger L1 cache and improved 16-bit performance, the slower and cheaper L2 cache's performance impact was reduced. General processor performance was increased while costs were cut. Variants: Klamath. The original Klamath Pentium II microprocessor ran at 233, 266, and 300 MHz and were produced in a 0.35 micrometer process. The 300 MHz version, however, only became available in quantities later in 1997. These CPUs had a 66 MHz front-side bus and were initially used on motherboards equipped with the aging Intel 440FX Natima chipset designed for the Pentium Pro. In Intel's family stepping scheme, Klamath CPUs are Family 6, Model 3. Deschutes. The Deschutes core Pentium II, which debuted at 333 MHz in January 1998, was produced with a 0.25 micrometer process. The 333 MHz variant was the final Pentium CPU that used the older 66 MHz front-side bus. All subsequent Deschutes core models used a 100 MHz FSB. Later in 1998, Pentium IIs running at 266, 300, 350, 400, and 450 MHz were also released. The Deschutes core supported FXSAVE and FXRSTOR instructions, as opposed to Klamath. The die size was 113 ohm-2. Towards the end of its design life, Deschutes chips capable of 500 MHz within Intel cooling and design specifications were produced. However, these were not marketed. Rather than destroy already multiplier-locked units, those Deschutes units that had been tested and locked with a multiplier of 5 were sold as being 333 MHz. This was accomplished by disabling the 100 MHz bus option. Overclockers, upon learning of this, purchased the units in question and ran them well over 500 MHz. Most notably, when overclocking, the final batch of 333 MHz CPUs were capable of speeds much higher than CPUs sold at 350, 400, or 450 MHz. Pentium II-based systems using the Intel 440 Lucis Balboa chipset were the first to utilize the new generation RAM standard, SDRAM, and the AGP graphics bus. Concurrent with the release of Deschutes cores supporting a 100 MHz front-side bus was Intel's release of the 440BX Seattle chipset and its related cousins, the 440MX, 450NX, and 440ZX chipsets. Introduction of the 100 MHz front-side bus speed resulted in solid performance improvements for the Pentium II lineup. The Pentium II Xeon was a high-end version of Deschutes core intended for use on workstations and servers. Principally, it used a different type of slot, case, board design, and more expensive full-speed custom L2 cache, which was off-die. Versions were produced with 512 KB, 1 MB or 2 MB L2 caches by varying the number of 512 KB chips incorporated on the board. In Intel's family stepping scheme, Deschutes CPUs are Family 6, Model 5 and have the part number 80523. Pentium II Overdrive. In 1998, the 0.25i1/4 M Deschutes core was utilized in the creation of the Pentium II Overdrive processor, which was aimed at allowing corporate Pentium Pro users to upgrade their aging servers. Combining the Deschutes core in a flip chip package with a 512 KB full-speed L2 cache chip from the Pentium II Xeon into a socket 8 compatible module resulted in a 300 or 333 MHz processor that could run on a 60 or 66 MHz front-side bus. This combination brought together some of the more attractive aspects of the Pentium II and the Pentium II Xeon. MMX support improved 16-bit performance and full-speed L2 cache, respectively. The later Dixon mobile Pentium II would emulate this combination with 256 KB of full-speed cache. In Intel's family stepping scheme, the Pentium II Overdrive CPU identifies itself as Family 6, Model 3, though this is misleading, as it is not based on the Family 6/Model 3 Klamath core. As noted in the Pentium II processor update documentation from Intel, please note that although this processor has a CPU ID of 163XH, it uses a Pentium II processor CPU ID 065XH processor core. Tonga, the 0.25ai1/4 M Tonga core was the first mobile Pentium II and had all of the features of the desktop models. In Intel's family stepping scheme, Tonga CPUs are Family 6, Model 5. Dixon, later, in 1999, the 0.25. 0.18i1/4 M Dixon core with 256 KB of on-die full-speed cache was produced for the mobile market. Reviews showed that the Dixon core was the fastest type of Pentium II produced. In Intel's family stepping scheme, Dixon CPUs are Family 6, Model 6 and their Intel product code is 80524. These identifiers are shared with the Mendocino Celeron processors. Core specifications: desktop. Klamath, L1 cache, 16 plus 16 KB, L2 cache, 512 KB, as external chips on the CPU module clocked at half the CPU frequency. Packaging: Slot 1 module, MMX, front-side bus, 66 MHz, GTL+, VCORE, 2.8 AV, process, 0.35 AA micrometer CMOS, first release, May 7, 1997, clock rate, 233, 266, 300 MHz, Deschutes, L1 cache, 16 plus 16 kb, L2 cache, 512 kb, as external chips on the CPU module clocked at half the CPU frequency. Packaging, slot 1 module, MMX, front side bus, 66, 100 MHz, GTL plus, VCORE, 2.0 AV, process, 0.25 AA micrometer CMOS, first release, January 26, 1998, clock rate, 266 euro 450 MHz, 66 MHz FSBA 266, 300, 333 MHz, 100 MHz FSB, 350, 400, 450 MHz. Deschutes, L1 cache, 16 plus 16 kb, L2 cache, 512 kb external chip on CPU module running at 100% of CPU speed, socket, socket 8, front side bus, 60 or 66 MHz, GTL plus, VCORE, 3.1 euro 3.3 AV, fabrication, 0.25 AA micrometer, based on the Deschutes generation Pentium II, first release, 1998, supports MMX technology. The S-spec number SL2KE denotes a Pentium II overdrive sold with an integrated heatsink fan combination for socket 8. Note that the S-spec number SL2EA denotes a Pentium II overdrive sold with an integrated heatsink but no fan for slot 1. Mobile, Tonga. Mobile Pentium II, L1 cache, 16 plus 16 kb, L2 cache, 512 kb, as external chips on the CPU module clocked at half the CPU frequency. Package, MMC1, MMC2, mini cartridge, MMX, front side bus, 66 MHz, GTL plus, VCORE, 1.6 AV, process, 0.25 AA micrometer CMOS, first release, June 7, 1997, clock rate, 233, 266, 300 MHz, Dixon. Mobile Pentium II PE, L1 cache, 16 plus 16 kb, L2 cache, 256 kb, on die, full speed. Package, BGA1, MMC1, MMC2, I1 quarter PGA1 PPGA B615, MMX, front side bus, 66, 100 MHz, GTL plus, VCORE, 1.5, 1.55, 1.6, 2.0 AV, process, 0.25. 0.18 AA micrometer CMOS, first release, January 25, 1999, clock rate, 266, 300, 333, 366, 400 MHz, containing 27.4 million transistors, die sizes 10.36 mm x 17.36 mm equals 179.8496 mm 2. See also, List of Intel Pentium II microprocessors, Intel Celeron, references. External links, listing of various PII, PIII, and Celeron alphanumeric model designations, CPU info, Intel Pentium II, in-depth processor history, construction analysis, Intel 266 MHz 32-bit Pentium II processor, Integrated Circuit Engineering Corporation, Intel datasheets, Pentium II, Pentium II, Mobile Pentium II, Mobile Pentium II in micro PGA and BGA packages.